I tried. I tried.
That's
Sorry.
too bad. I should just leave it down there. No. Okay. So the problem somebody asked me about earlier, it's in section 7.3, but notice the instructions on it. It was number 12, I think. You guys see number 12? I think it was number 12. It was something like number 12. If you see that, and look, they say evaluate the interval. Did they tell you how?
Mm-mm.
Now, one given is you're not going to just throw in Wolfram Alpha or some shit and just put the number down. But the method you use doesn't have to come from this section. What do you rule out always before you do something weird? Before you do trig sub, before you do trig intervals? What do you rule out? U sub, and will U sub work? Huh? Will U sub work in number 12?
Yeah.
Because what's the part that's stuck?
The X.
The 36 minus x squared, and what's its derivative? Something x. And isn't that on the top? So that U sub will take care of that all day. You guys with me? Okay, maybe. So I'm completely cool with if the instructions say evaluate. It doesn't say evaluate using trig substitution. I desperately want to see you guys do number 12 with U sub. Of course you should, because that's the what you should use. Now, you could try trig sub to get some practice, but you got other problems that you're going to get plenty of practice. So, you guys are with me? So if the instructions aren't specific, if they just say evaluate it, you're allowed to use whatever is the best method in that case. Okay, now don't get excited. There's not a ton of these where U sub will work, but that's one of them. Okay, maybe. So real quick thing, the quiz on Tuesday is going to have problems from 7.1, 7.2, 7.3, and I'm not going to tell you when to do what. So part of what I'm testing you on is, do you know how to tell when to apply which method? Yes? Okay, maybe. So we're going to do 7.4 eventually here. And the thing about section 7.5 is basically 7.1 through 7.4 just thrown in a frickin' blender and then put on a page. Yes? 7.5 is the just, here's 7.1 through 7.4 problems. Pick which one is which and do it. Yes? It's just all of it mixed together. I guess with okay. All right. So looking back at 7.2, I had a really good discussion earlier with somebody about an issue I didn't really necessarily consider. What was can somebody give me one identity for this?
Oh, 1 half, 1 half. Oh my gosh, what is it? 1 half, cosine.
1 minus.
1 minus cosine 2x.
Good. Now. No, you already got the 1/2.
Because of 1/2.
So it's either all over 2 or you put a 1/2 up front, correct?
Yes.
You can memorize that if you want to. You can memorize this fact and solve for sine squared so you don't have to memorize this separately. It's up to you. So when I teach trig in trig or I teach trig in my pre-calculus, I try to get people to understand you don't have to memorize every damn identity. You can memorize some and then build the other ones when you need them. It's up to you how you do it. Somehow you got to get in your head because that's just, you got to memorize it. I'm sorry, that's all there is to it. Can somebody else give me another identity for that? That's not the only one. What's the more basic one?
Cosine squared minus 1?
Nope.
No.
1 minus cosine squared?
Yes, because
Oh.
what do you get when you add sine squared and cosine squared?
1.
You get 1. So, I mean, this happens so much in mathematics. Two things create a total. So total minus one thing is the other thing. Total minus one thing is the other thing. You see that a lot. Right? So sine and cosine squared, you square them, and then you make one, then 1 minus one of them is the other one. Guess what? And that one feeds directly into trig sub. This one you use whenever the hell you have an integral of just sine squared or just cosine squared, yes? Because what's the cosine squared? What's the only difference with the cosine squared expression?
It's a plus.
It's a plus, yeah.
instead.
Because cosine's an asshole, so he left the plus for himself. Okay. Or you don't have to think of it that way. You really don't. Just want somebody to say that to the next teacher, and they're like, what are you talking about? So if I see this, do I need to use the sine squared identity?
No,
Why not?
because you could just use u sub and it would end up
Because I
being u
have
squared.
an extra cosine floating around. So cosine x dx, what would be u to make that du? What would it make u equal to make du cosine x dx?
Sine x.
Sine x. And then I got sine squared, so that would become u squared. You guys see that? That's the whole idea of this trig integral of section 7.2 is it's a specific application of u sub. Since sine and cosine's derivatives are related to each other and secant and tangent's derivatives are related to each other, when you have both of those in one, you can use u sub in kind of creative ways. Okay. Maybe. Now, real quick, what if I had, let me see, what if I had this? Okay. So do you guys see that the right way? I tried to introduce this the exact way you should look at it. What tells you what to kind of move to the side? Yeah, what is there extra of? And I love that it seemed to me like everybody kind of got what I meant. If I wanted both of those to be even, what is there extra of? There's an extra
Sine.
cosine, right? So if I just move that over, this is the whole idea of this entire section. Again, it tells me what du should be, yes? I want du to be cosine x dx. So then what must u be to make that happen? Sine x.
Sine.
So if I let u equal sine x, du is cosine x dx. That kicks so much ass, because then that could just become du. This could just become what?
U to the 6.
U to 6, great! But what's the last dude I gotta do something with?
That, then you have to multiply it by u to the 4th.
Nope, what's u? U is sine. I have cosine to the 4th. How do I write that in terms of u?
du.
No. We tried it. Remind me. What is sine squared?
Has to be an identity for it.
1 minus cosine squared. So what's cosine squared?
Cosine plus.
1 minus
Oh, sine.
sine squared. So how do I get cosine to the 4th? What do I do to this? Square it. If I square that side, I better. Yes, so you can replace this with this. And what is my motivation for doing that? I know u is sine x. So everything that isn't du, I needed to have a freaking sine x in it, so I can put a u there. Stupid cosine to the 4th. You suck. I need you in terms of sine, so then I can actually plug a u in. Do you guys? So I have kind of two levels of identity to worry about. If I only have an even power on my trig stuff, on the sine and cosine, I have to use the 1/2 1 minus cosine or 1/2 1 plus cosine 2 theta, yes? I have to use that. If the issue is the piece I have is not matching with my u, then I have to use the Pythagorean identity. The issue here is I don't want cosine, I want sine, so I can put u there. Yes? The issue with integral of sine squared is I don't want the square. I want to get rid of the square, so I have to use the power reduction formula, the freakier one. Okay, maybe. So what's the entire motivation here? I want to get all my x business replaced with u. That is what motivates every step I take. Okay, maybe. I still love you guys. Never poker. Poker's never happening. We're never going to have a poker night. You guys will kick my ass. Okay. All right. Any questions on that? Okay. Okay. I'm not going to say any more about it until you guys come with questions. So, what we're going to focus on tonight is 7-4. And to get there, I want to start with an idea that I'm really happy I remembered. I like to start with this. So, let's see if you guys feel the same way. Arg. How much paper I've got? Not much. Just got a lot of writing on it. Okay. So let me ask you this. Okay. I'm going to talk right now about a little skill that we have to have in order to do the process for 7-4. We need to have this skill locked down. Let's say that I know that 6x squared plus 4x minus 3 equals ax minus bx squared plus c. Can anyone tell me? Now I'm telling you, that is true. That is true. I don't know if any of you right now are like, how the shit I'm going to solve that? Because I don't want you to solve for x. Can anyone tell me what a has to be?
4.
Does everybody see a side of frickin' 4? That's the only way that this has a chance to be true is if the coefficient of x on one side is the same as the coefficient of x on the other side. You guys with me? So this, remarkably enough, if you've done partial fractions before, you know exactly what I'm doing. This is called equating coefficients. So in this case, a is 4. What's b?
6.
Why is b not 6? Yes, negative b is 6. So what's b? Negative 6. And what's c?
-3.
Negative 3. Cool. Is everybody with me? That's a remarkably simple idea. Let it be simple. So I'm not asking you to solve for x. I'm actually just asking you, what do the coefficients have to be? And it sort of tells you. So let me go one level up from this. So what if I had 5x squared minus 7x plus 11 equals a times x minus 2 squared plus b times, nothing too crazy, Jeff. Sure, x plus 1. This is fine. How would I start to investigate what a and b are? And by the way, real quick, a and b are like a level above a normal variable. X is my variable in this, yes? But a and b are, you know this word, they're called parameters. And they're always kind of like another level above a normal variable. Kind of behind the scenes or whatever. So once I set a and b, that's going to make the equality true. It's not like a real basic level variable. Okay. What's the difference between this and this? Why was this easy?
They're in the same form.
Yeah, they're in the same format, right? This is already multiplied out. So what am I going to do with this business?
Multiply it.
Multiply it out. That's silly. Okay. So I got a. How do you FOIL this? Yes? And then you get ax squared minus 4ax plus 4a plus bx plus b. Now you got to be a little more careful, right? Same idea. So what must 5 equal? This one's easy. What must be 5? A, because it's in front of the x squared, and what's the only thing in front of the x squared on this side? A. So in order for this to have a chance to be true, a must be 5. What's negative 7 equal? Nope. That's part of it. Nope. What's in front of the x? On one side, and it's a negative 7. What's in front of the x on the other side? You can do it.
For a negative 4a.
Negative 4a plus b. Yes? If you wanted to, you could even rewrite this and do like, let's see. Collect things, collect my x's and add their coefficients. Collect my numbers, yes. So what must negative 4a plus b equal? It must equal negative 7, because that's what's in front of the x on this side, yes? And what must 4a plus b equal? 11. Kick ass. Now, does anyone see something really, really nice? Do you guys see the kind of math you're going to have to do sometimes? What can you do with these two? I know A is 5. A, you're the real MVP. You kick ass. Now, real quick, I could put a 5 in for A, but pretend like I don't know A is 5. What can I do with these two things? What do they want to do? Yes, if I add them together, yes? You remember solving systems of equations, yes? If I just add these together, the A's cancel. What do I get? These cancel. I get 2b equals 4. So b is 2. Cool. So now I know what A and B are to make this statement true. Okay, let me stop for a minute. So this is called equating coefficients, and it is a skill we need to be able to do section 7.4. Has anyone ever done this kind of thing before? Do you guys remember doing this ever? Nobody. Okay. Does it make some sense? I mean, you guys got that first problem really quick. The only way I can make it worse is to have more shit in front of x, and more shit in front of x squared, yes? Then you have to collect all that stuff together and set it equal, and then you have to solve systems of equations. Okay. So, that's now in our tool chest. We can bring it out whenever the hell we need to. Sweet. So, let's look at the actual kind of problem we're going to do. I'm going to do something in reverse. I think I did this with you guys last time, but let's do it again real quick. Right, if I want to add these together, what do I need? Common denominator. So this guy needs, what's this guy need? An x minus 2 to make him start to look the same as this guy, and then this guy needs
X plus 1.
freaking x plus 1. Now they got an LCD. So I get x plus 3x is 4x. Negative 2 plus 3 is 1. All over x squared minus x minus 2. Shabbat. So what's going to happen now is we're going to be given this, and we have to try to break it back apart. And that's always more difficult. You guys semi with me? So let's go ahead and do this. Since we already know what the answer is going to be. We already know the answer should be 1 over x plus 1 plus 3 over x minus 1. We know it. So let's see if that'll help you buy into this process. So let me write this down here. What do you think is the first step in this process to try to break this fraction up?
To the bottom.
Factor the bottom, because that's breaking the bottom up, and then that tells me how to try to break this fraction up. Yes? I can't. No, that would Jeff. You want? So on the bottom, I'm going to bring back x plus 1, x minus 2. So all this is kind of like background. Pretend like I just gave you this and I said, break this up. And our motivation is, if I ask you to integrate this, you cannot, or at least you could, if without doing this, it would be not nice. I'll just say that. Now, listen, what is the only way, what do they look like, the fractions this could have come from? Why does it have that bottom? It must have come from a fraction with what on the bottom? Must have come from something with an x plus 1 on the bottom, and there's something with x minus 2 at the bottom. Okay. So I don't know what the top is here, and I don't know what the top is here. Can anyone tell me? All right. Let's not bring that in yet. Yeah, okay. I'm not going to bring that in yet. Okay. So here's what I do. So if I'm given a fraction to break down, I factor the bottom, and that tells me what form to put the answer in. So I just wrote the answer in an algebraic way. Like, I don't know what A is and I don't know what B is, but I know the answer looks like this. Now I'm going to use that fact. I can now multiply both sides of this equation by the LCD. All the fractions die. Yes? It's always nice to sit there and watch a fraction die. So if I multiply both sides by this, what happens? Yeah, I'll do this side. Whew, okay, I did half of it. What happens over here? If I multiply this, what happens here?
The x plus 1 is going
X plus 1 cancels, correct? So the A effectively picks up
the x minus
the x minus 2, because the x plus 1 canceled and the x minus 2 is still alive, yes? So what happens with the B? It effectively picks up
the x plus 1.
the x plus 1. So you all know this. If I have an equation, it's got fractions in it, something I can do if I want to, and we definitely have to do it here, I can multiply by the like denominator, because it'll kill all the fractions. Now, I'm going to show you the way we did just a minute ago, and then I'm going to quickly follow it up with a shortcut that I could do. I can almost always use your shortcut at least a little bit. So let's first do it the way we just were doing it. How would I do it the way that we first did today? What would I have to do right now? What would I have to do it the way we were doing this guy? What would I have to do?
Figure out what 4x equals and what 1 equals. I would just go
Yes. Okay. So if I can multiply these in, I can then collect everything that's in front of x. Yes? Now, do I have to rewrite this? Can you guys see what's in front of x? On one side it's 4. On the other side it's
a minus 2.
no. You can even underline for yourself. Where are your x terms? So what's in front of x?
Oh, a plus b.
Yes, a plus b. Okay, what's the other equation I can set up? What's the only other thing? Yes, b minus 2a must be 1. Number and number together must make 1. Yes? How do I know these are numbers? Because they don't have any x's. So b minus 2a must be 1. Any suggestions on how to solve that system of equations? Multiply again. Okay, multiply the first one by negative 1. Okay, so if I multiply this by negative 1, I'll get negative a minus b equals negative 4, and if I add those together, what happens to the poor little b dudes? They die. Horrible death. Negative a plus negative 2a is negative 3a. 1 minus 4 is, so what's a? What's a? 1, yes. Now how do I figure out what b is? Well, a plus b is 4. If a is 1, then b must be 3. Good. Okay. And does that match up? Well, where was A? Where was A? How would I write my answer now?
1 over x
Here. Yeah,
plus
yeah, I'm
1
sorry. Yeah, 1 over x plus 1.
plus 3 over x minus 2.
Which of course is where we started earlier, yes? Okay. So this process, the level of mathematics in it is very low. We didn't do any funky math really at all. It just can get a little unwieldy if you have a lot of A, B, C, D, right? I mean, if I factor the bottom, it's got a lot of parts to it. I'm gonna have more and more of these, yes? Okay. So let's talk about what could happen, because this is very simple. What's the degree of both of these? The bottoms, first degree, right? And none of them are repeated, like none of them have a multiplicity. If I say the word multiplicity, are you guys cool with that? Meaning none of them show up more than once. It's not x plus 1 squared, that would show up twice, yes? Okay. So, let me ask you guys this. What if I had, oh, this could get gross, but too bad for everybody. What if I had this? So I've already factored the bottom for us, yes? Is this so if I ask you, is 11/10 a proper fraction? No. Is 10/10 a proper fraction? No. Is 9/10 a proper fraction? Yes. Is the degree on the top smaller than the degree on the bottom? You can do it. What's the degree on the bottom? 3. Good. Squared and another x of third power on the bottom, right? So that is a proper fraction. So then I can apply partial fractions. If the top was cubed, I would have to try long division first, and then use partial fractions on whatever was left. Let me ask you guys, can somebody give me an idea where this came from? What could the answer look like? And it's okay if you get this wrong, but can anyone tell me for sure what piece would it have come from? Like we did earlier, this guy came from something over this piece and something over that piece, yes? So help me out. A over x, I love it. Good start.
And then b over x plus 4 squared.
All right, I love it. Now, it's not quite done yet, but this is beautiful. And I want to focus on why that's not quite done yet. Okay. Side note, little sidebar. If I have 2 over x plus 4 plus 3 over x plus 4 squared, I'm not even necessarily going to do this. What will the bottom end up being? Can you guys see what the bottom is going to end up being? What would the LCD be? Who needs something? Do they both need something? Do they both
No.
need something?
No.
What's the only one that needs something to make the bottoms the same?
The 2 over x plus 4.
Yes,
is
so
another
what will
one.
the answer's bottom end up being?
X plus 4 squared.
So I need you to see how something over x plus 4 squared could have come from something over x plus 4 plus something over x plus 4 squared. If I put just this, that's not enough. It could have come from something over x plus 4 also. I really want this to make sense. So if I have 2 over 1 x plus 4 plus 3 over 2 x plus 4, it equals something over x plus 4 squared, yes? So if I have an x plus 4 squared, if I have any repeated term, and very quickly, do you guys see there's 1x down there, correct? What is there 2 of? X plus 4. And what's the degree of x plus 4? Good, first degree. So there's 2 first degree dudes, right? They repeat. Okay, I like it. I like it a lot. It's going to come in really handy in a minute. Do you guys see how, what's the degree of the bottom here? First degree, what's the degree at the top? No? 0. No x's up there. So it's a 0th degree. Isn't this a number? And the degree is the number of variables I see in a term. No variables, 0 degree. What's the degree of this? Let's go this guy. What's the degree of this guy? First degree? 0th degree. Now, here's the tricky part. This is the repeated x plus 4. So what's the real degree? First degree. That 2 just means it's repeated another time, yes? And the top is 1 degree less. So when you're doing partial fractions, the top expression has to be 1 degree less than the bottom expression. Otherwise, you could reduce the damn thing. Maybe? Okay. Whatever you say, Joe. Okay. So you guys see there are 3 parts to this, but they're not what you thought they would be. There's an x, there's an x plus 4, and there's an x plus 4 squared. Those are the 3 things that could combine to make something over this. Okay. So what if it was x plus 4 cubed? What would happen over here? There would be a d over x plus 4 cubed. Exactly. So whatever is repeated shows up that many times on the other side, yes? Okay. Maybe. So how do I go from here? What do I do? Once I get this set up, it's something I call the SDT level, the same damn thing. You kill your fractions, you equate your coefficients, yes? And I completely forgot to show you the shortcut on the other one, because that's going to come in handy on this one. I will do it on this one. It's okay. I'll show you the shortcut on this one, because this one, you got 3 unknowns. It's going to be kind of a gross system of equations. You guys with me? Okay. So can you multiply both sides by the LCD? And here's a beautiful way to think about this. I'm going to multiply both sides by this business, yes? So this guy, whatever's underneath cancels, and it picks up the other 2. So you can very quickly see this is just going to pick up these guys, yes? What is B going to pick up? Just an x, because that kills those 2, yes? And what does C pick up? An x and an x plus 4. Kick ass. So you don't have to write all that shit out. We're past that. We're in freaking Calc 2. We don't need to write all that shit out. I can just see what each thing's going to pick up. Now, here's a beautiful trick. Do you guys see how this would be kind of gross to multiply all this shit out, gather, and then you're going to have a plus 4b plus 2c equals 7. Oh, God. It's doable. If I forced you to, you should totally be able to do it. It's not like hard. It just takes a while. So tedious. That's a beautiful word. So let me ask you this. In this expression, can't x be whatever I want it to be? Yes? X is the true variable in this whole problem. So let's let x equal something smart. Say again? Why is x equal to 0 smart in this case?
Because then all
Because then
the
these
x's
2 terms die and I can solve for freaking a. Yes? So what happens if I let x equal 0? What do I get on this side?
1.
1. And then here I get 0 plus 4 squared.
16a.
Good. And then these, of course, go to 0, yes?
Mm-hmm.
So what's a?
16.
No, come on.
No, 1/16.
1/16. I like it. Your brain says, no. And you're like, sorry, brain, it's just freaking 1/16. And why is it so gross? I just made this up out of nowhere. So I can guarantee that the ABC is going to be gross when I just make it up. But why are we not concerned? Because this is relatively easy. What's another good thing to let x equal?
1.
No. What else would kill some of these?
-4.
Negative 4.
Oh.
I think I heard somebody say that, so thank you. So on this side, what do you get? 3 times 16, 48. Plus 16 is 64. Plus 1 is 65. What do you get on this side? These 2 go to 0.
Those 2 are 0.
And this is negative 4b. So B is
Negative 65.
negative 65 over 4. Yeah. Okay. Is that the answer you wish it was?
No.
No, too bad. Now, are there any other values of x that I could use to help me do this? We kind of used them up, right? There's no other values of x that make things negative. What's the only letter that I don't know yet? C. Does anyone see how to, there's several different ways you could do this. I could plug A in, plug B in, multiply that shit out, add it, oh my god, don't do that shit. Can somebody, now we kind of sprinkle in the first method we did. So for example, do you guys see how there would be a C in front of an x squared? If I multiply it out, what's the only other letter that would be in front of an x squared if I multiplied everything out? A. So what's true then? A plus C has to be what? So I get ax squared here, yes? I get cx squared here, so what's A plus C have to be? 3. So this is the most work you have to do in this problem. Where these were, I'm not really going to count these as work. So this is 1/16, right? Because that's what A was. Plus C is 3. So what's C?
2 and 15 sixteenths.
Oh yeah, sure. 2 and 15 sixteenths. Yeah.
360.
Or you can do 3 is 48 sixteenths. Yes. No. Yes. 48 sixteenths minus 1 16th is 47 sixteenths. Either way. So help me out real quick. What's the answer? How do you rewrite this? How do you break this guy up? You do it.
3. Wait.
How do you break this guy up? We figured it out. A is 1/16, yes?
Mm-hmm.
So how do you write that?
So it'd be
Here, I'll help. 1 over 16x, yes? Plus? Well, actually, what would it be? What's
would
b?
be minus.
Negative, so minus 65 over 4x plus 4 squared, yes? Plus 47 over 36x plus 4. Okay. So this is kind of like a puzzle, which is good. I'm not asking you to like this as much as I do. I love this shit. This is such a beautiful idea. And you see this idea of equating coefficients, this kind of idea, show up several times in mathematics. This is kind of like the first level you see that. Let's talk about the last possible situation. So what if I had this business? What you got, Jeff? I don't know. Oh yes. Which numbers? So up here, I can pick whatever I want for x. X is my true variable. If I pick x to be 0, why did I pick x 0? Because then these two die. The whole problem with this is there's too many freaking unknowns. So if I could directly kill B and C, I could solve for A. So if I make x 0, this side becomes 1, this side becomes 16a, because this is 0 and that's 0. So 1 equals 16a, a is 1/16. Then I said, oh cool, is there anything else? Oh yeah, -4 will kill a couple of these dudes. So I let x be -4, this side I got 65, this side I would get 0, 0, so I get -4b. Is that cool? Okay, okay. So what's different about this one? Do I have any repeated, oh sorry, go ahead.
For the last question,
Yeah.
for C, should it not be 47 over 16?
Do it, I'm sorry?
This is 36 to 47. Should it not be 16 instead?
Oh, 16, yeah. I don't know why I put 36. Thank you. Okay. On this problem, are there any repeated parts? No, good. X minus 1 is what degree? First. X squared plus 7 is what degree? So second, definitely, right? And what did I say earlier? The expression I put over the part has to be 1 degree less than it. Yes? So I know, let's start off with the easy one. I know there's got to be something over x minus 1. Since that's the first degree, I need a 0th degree on the top. For this one, x squared plus 7, what kind of degree expression do I need on top of it?
A first.
First degree, I need a linear dude. I need an mx plus b kind of situation. So let's use what 2 letters next? Yeah, bx plus c. So if it was x cubed plus 7, I would have had bx squared plus cx plus d. The most general second degree dude would go on top of a 3rd degree piece. That's basically everything that can happen in partial fractions. So then I would do all the same business, yes? What would I do next? Besides skip it and hope I don't notice?
Kill the fractions.
Kill the fractions. So A would pick up x squared plus 7, and the bx plus c would pick up an x minus 1. So very rarely can you use the x equals a number trick all the way down. There is one number I can do here. So what I normally do is I try to use that trick at least once, and then I don't have such heinous systems of equations after that. I really want everybody with me. I could right now say a plus b must be 0 because it's ax squared and bx squared if I multiply that out, correct? Okay. But I don't have to start there. What could I start with? What could I let x equal? 1. Because right now my whole purpose is to figure out what a, b, and c are, and if I kill this piece, I can solve for a easy. And sure enough, if I let x equal 1, that's my little assassin dude gonna kill this guy. What do I get on this side? Holy shit. This guy dies. If I let x equal 1, I get 8a. So I get a is 1/4. So now we got a bit of a conundrum, but it's not, we still have to do a little bit of the other way, but now I know a is 1/4, yes? Sorry, there's a lot of different things I could do. I could go ahead and start doing a system of equations, but then I could replace a with 1/4 and try to solve for b and c, correct? And that's like your traditional thing to do next. What I sometimes tell people to do is put a 1/4 here, because I know a is 1/4. Multiply everything by 4, so that becomes 1. Distribute. Put those on the other side, and then equate coefficients, and I have one less letter to worry about. That's the trippier way to do it. So let's do it the more traditional way. Can you guys tease this out? Do you see how there would be an ax squared and a bx squared? And there's no other x squares? So I know a plus b has to equal what? 0. And automatically I know what b is, yeah? If a is 1/4, b has to be negative 1/4. Can you do something similar for c? What's the easiest thing that c is involved in?
It's in with B.
Okay, it's in with b. So I could
The
either,
BX
I really want you guys to see that. What's the constant term from this dude?
A.
7a, right? And what's the constant term from all this shit? You don't have to multiply it out, do you? What's the only constant term you would get?
B.
No.
Minus c.
You get bx squared plus cx minus bx minus c. That's the only constant term you get, correct? What must 7a minus c equal? Must be negative 1. It must be the constant term. The part that's constant over here must equal the part that's constant over there. If you understand where a plus b equals 0 comes from, you understand where that comes from. Same place. Does everybody understand why I wrote a plus b equals 0?
No.
Okay, so let me So, I'm gonna request your help. Did you hear how many people said no right then? Okay. Take that to heart. If you're sitting there and you're like, all these other people understand what the shit this guy is doing, I'm not gonna slow the class down, I'm not gonna ask. A lot of people had no idea. I don't know you didn't know. I don't know, because nobody said anything. So, please, dear God, the minute I do something, I am beyond cool. You guys are a little quiet. I'm cool with, give it to me. Part of my job as a teacher is to know when I can't answer more questions because I gotta keep going. So do not self-censor. Do you understand? Well, self-censor in terms of, but in terms of asking me math questions, don't stop yourself. Don't go, I don't want to take time. Does that make sense? Please help me. Please help me. It's a little Jerry Maguire. Help me help you. Okay. Can somebody tell me why a plus b is 0? Does anyone understand? Yes.
So if you do the distribution from the bx plus c times x minus 1, you get bx squared.
Yes. So over on this side, how do I get x squared terms? Wouldn't it be ax squared? And wouldn't it be bx squared? Yes? So ax squared plus bx squared must equal 0. So a plus b must be 0. Because what's the x squared over here? What's the coefficient? Must be 0, because there's none of them, yeah. Okay. So it's still the same idea we started with. It's still equate the coefficients. If you need to, go ahead and FOIL that stuff out, blah, blah, blah. I'm not going to. You don't have to do this, but you really should be at a level where you don't have to do it. If you do, go ahead. It's okay. But you should be able to say, okay, this is going to be this is going to be this. So then I can move on to what's the constant terms, because I know they have to become -1. 7a is a constant term. -c is the other constant term. So when I put those together, they better freaking make -1. Okay. And why is that nice? Because I know what a is. So I got 7/4 minus c is -1. So if you solve that business, you get, well, you get 11/4. If I did it right. Add c, add 1, 1 plus 7/4 is 11/4, yeah. Okay. So just to point out, I've got on the reverse side of this one, I've got explanations and examples of all the different situations that could happen. I even have one example of the alternative method. So I want you guys to try out, just to start with, just take the inside of that interval and apply partial fractions to it. The full name of what we're doing is called partial fraction decomposition, because when something decomposes, it breaks up into its parts. So we are finding little dead fractions and letting them decompose. What'd you do today in math class, honey? What? Not. I love it. Let me put this up here for everybody here. Where'd it go? Here it is. People at home, this is the work for them. truly, I hope you see the difference. There's the repeated, so it's just whatever is on the inside, it's linear. Or there's x squared plus 7 where you can't break it down. So it's officially called an irreducible quadratic, so it's truly second degree then. Yeah. Let's see. Haven't done this problem in a while. Let's see. So to make sure everybody's on the right track, what does this look like? Kick ass. Okay.
Wouldn't that be BX over?
Nope. Definitely not. What's repeated? What's the degree of the piece that shows up more than once? Linear. The top's always got to be 1 degree less than that. The square is just, it's repeated a second time. Yes? And I'm going to show you a concrete example about why if you put bx plus c on the top, that's extra shit. You're just giving yourself another letter to worry about. You don't need to. I'll show you a concrete example about why you don't do that. What's up, Sarah? The bottom's only got 2 parts, right?
Yeah.
So it kind of makes that I'm expecting 2 things, and it's a repeated thing.
Yeah.
Okay. And it's repeated linear. So the tops are just going to be numbers. And the
Yeah, I
bottom is
understand
gonna-
that.
Okay.
It's just like the bottom, like you have x plus 2 squared, but down there it would be x plus 2 cubed.
What do you mean?
You have an x plus 2 squared.
Sure.
X plus 2. That's
Oh,
not
no,
the
no,
same
no, no,
thing
no,
as
no.
x
Of
plus
course not. Of course not. Of course not. If I add 1/3 to 1/9, am I going to get something over 27? Of course not. I'm going to multiply this by 3 and get something over 9, correct?
2. Yeah.
Okay. And why does that work? Because this is 3 squared. So he doesn't need shit. He needs something.
Oh.
So you would give him an x plus 2, and that would match with him. Yeah. Okay. It's just because it's repeated. That's why it's kind of a special little case. No, E minus 2. Thank God. E minus 2. I think past Jeff did that on purpose to make a log you get in the future come out nice. I already kind of see where I'm going with that, but you never know about past Jeff. Oh, did I start that? Yeah, I did.
Yeah.
Now I'm rolling. Okay. So let me catch up to you guys a little bit here. So what's this guy gonna pick up?
And x plus 2.
X plus 2. And what's gonna happen with this guy?
He's gonna die.
B? That kicks ass. So let's do this with the other one. Why not? If x is, what would you let x equal? This is kind of dumb. I mean, do you guys see how this is silly? What's A? You can see it, right? What's A? 2, yes? So there's a lot of little ways you can do this really, really quickly. I mean, that you can't just get away. That is A is 2. A is the only thing in front of x, so it must be 2. Now don't say B is 2, yes? That's not right. what's 2a plus b?
2.
That's 2. So 4 plus b, right? Because a is 2. 4 plus b is 2, so b is negative 2. Okay. So you have many, many options in a lot of these in terms of how to, you could do entire systems of equations and never pick a value of x, right? You can pick as many values of x as you want to and then do the rest with systems of equations. You can do these a lot of different ways. Yes? Say again? Oh, okay. So if I multiply this out, I'm gonna get ax plus 2a plus b. Right? Ax plus 2a plus b. Yes? So what's 2a plus b have to be? What does ax have to be? So therefore, what does 2a plus b have to be? I need you to see this. What's in front of x on the left-hand side? 2. What's in front of x on the right-hand side? A. What doesn't have any x attached to it on the left-hand side? 2. What doesn't have any x attached to it on the right-hand side?
2a plus b.
Therefore, 2 must equal 2a plus b. The only way that statement can be true is if the numbers on one side add up to be the numbers on the other side. And what are the numbers on, it's 2a plus b are the numbers, yes? So they must add up to be 2. Oh, sure. Wait, so I could have picked x to be negative 2, yes? I'm not sure if that's what you're asking.
Like when you do that, when you get the like squares.
Yes!
You know what I'm talking about? Like
Yes.
So that's what that is.
That first thing we did is the entire idea of this. Whatever's in front of the x on one side must equal whatever's on the x in front of the x on the other side. That's the only way the equality could be true, yes?
Yeah.
Whatever doesn't have an x on one side must equal whatever doesn't have an x on the other side. Same idea.
And you tell by the power of it.
And you tell by the variables, yeah.
Yeah. Okay, so because the 80 x is power 1 and on the other side it's 2x power 1. Those are the
Yes,
same.
yes, and that's
Everything
why,
just left over regardless of what it is has to equal the rest.
yeah, and that's why on this problem, we knew that, shoot, where'd it go? Not that problem. Here we go, this one. We knew that a plus b was 0 because ax squared plus bx squared, but there is 0x squared on that side, therefore they have to add to be 0. That's the only way this could be a true statement. Exactly. Okay. Now, what does my integral become? Was e minus 2 to 1. What does this become?
Uh, 2 over x plus 2 plus, or minus technically.
Oh yeah, so b was negative 2, yeah. So we get you to minus 2 over x plus 2 squared. Okay. So what is this one? What is this one? Yeah. And what is this one? Is it a natural log for that one?
No.
Hell no, because the power is not 1. Right? It only works if it's 1 on the bottom, the negative 1 overall power on the variable piece. That is a negative 2 power. So what is the integral of x to the negative 2?
Negative x plus 2 to the,
Well, no, what's just the integral of x to the negative 2?
oh,
So negative x to the negative 1, yes? And you add 1 to the power and you divide by the new power, correct? Alright, so what's the integral of x plus 2 to the negative 2?
negative
Negative
x plus 2,
x plus 2 to the
negative.
negative 1, yes? Same way. So quick side note, and we still have to throw this stuff in here. Okay, what is the integral of 1 over x? ln absolute value of x. What is the integral of 1 over x plus 11? Natural log of the absolute value of x plus 11. Okay, so if the only difference between a basic thing and this is I've added stuff to, so it's like still linear, slope 1, no thought, 0 thought. If that's natural log of this is natural log of that. The only time you have to be careful is if I had something like, is the bottom of first power. Yes, so it is a negative 1, so it would become a natural log, correct? Okay, so it is ln of 2x plus 3, but why is that not right? Potentially. Well, let's see, is it right? What's the derivative of this?
2.
What's the derivative of this?
Oh, the whole thing.
Yeah, derivative of this, yeah.
1 over.
Yes, 1 over
2x
2x plus 3 times
2.
2. Good, so I just divide by 2. I mean, we've seen that shit before when the inside function is linear. I don't need u sub. I just divide by the slope of the damn thing, because that's what chain rule would have come out, and if it wasn't there, I'd better kill it. I really want you guys to see that. Don't do u sub everywhere. You don't need to. It's linear. Screw it. We're humans. We got you. It can't just be ln 2x plus 3, because the chain will have a 2 come out. Let me kill the 2. Kill it. Because it's not there. Maybe? Maybe. Now, if you did u sub on this, I'm not going to take points off. I'm just trying to show you that's extra work. Don't waste time doing that. Okay. Maybe. Now, what about this? Now, what's a better way to write that?
X and negative 3.
Good. Now, apply the rule. What's the rule for x to the n? Integral rule.
X to the n plus
Good.
1
Add 1 to the power,
divided by
divide by the new power. So that's exactly how I do it. Add 1 to the power, divide by the new power. I mean that. Okay. So how about this? So what is integral of 1 over 4x plus 5 to the 4th power? That would be integral of 4x plus 5 to the negative 4th power. Is the inside linear?
Yeah.
Screw u sub. We don't need that shit. What is something to the negative 4th power? How do I take that?
It would
Integral.
be it would be negative
It'd be that thing to
1/3 to the negative 3rd.
It'd be to the negative 3rd. Yes, good. And then divided by the new power. But what else do I have to divide by? 4, because the chain rule would have a 4 come out, yes? Plus c. Okay. Do you guys see that? Do you guys see that? Now again, dear God, if you saw that shit and you want to do u sub because you're like, I hear you, Jeff, but man, let me just do this shit. I'm not going to take points off. Yes, just if you do that multiple times and you're complaining about time, I'm like, that's all on you. You chose that path. Okay. All right. So coming back to this, I think. Oh boy, here it is. Oh God, thank you. I never know where I'm going to put these papers. Okay. So we got to here, yes? So let's put some stuff in here. What do you get when you plug a e minus 2 in? Well, let me put a 1 in first. What do you get when you plug 1 in? You get 2 natural log of 3 minus, and like you said, when I plug in e minus 2 in, e minus 2 plus 2 is e. What's the ln of e? 1 times 2. 2. Okay. And what do you want to plug a 1 in here? 3 to the negative 1 times 2, so 2/3. Is that cool? Minus. Plug in e minus 2. E minus 2 plus 2 is to the negative 1, so that becomes 2 over e. Thing of beauty. Do I put plus e?
No.
Of course not. Good. It's a definite integral, so the c's would cancel. Yes? Maybe. So what partial fractions does is it puts it into a form where I can expect some logs to show up, but they don't have to, because maybe it's a squared piece, and then it's going to become a negative 1 power when I integrate. Yes? Okay. Don't be scared to do U-sub. You can do U-sub. I'm sorry, I'm kind of emphatic about it, but I desperately want you to start being more to the point with your work, so you don't waste time writing all this extra stuff you don't need. Okay. All right. So you're going to want to practice with this. Well, section 7.4, you're going to have a lot of practice with partial fractions. Okay. So let me ask you this: do you guys want to do one more example of that, or do you want to do the next thing I was going to do? Which? Up to you. I'll make it a democracy. One more example? Okay, so let's pull it right out of the textbook. It comes out of my, but it's going to look horrible. Let's see. 7.4. I don't know. Well, looks good. Come back. Real quick, let me ask you this. Do you guys see, like this one, is this a proper fraction in terms of polynomials? Yes, the degree on the top is 1, the degree on the bottom is 2. The degree on the bottom is higher, proper. It's not top heavy and it's not equal. Yes? It's just like normal fractions. Where do you see an immediate problem? Anybody see a problem in regards to what I just said? Look at number, what is that, 15? What's 15? Top heavy. So what can I do? Long division. Or synthetic. If you set it up and remember your zeros. You guys kind of with me? How do you make a mixed number? Long divide the things. Or you can be nifty about it, but it's up to you. Let me show you something real quick. Just to get you guys thinking. It's kind of cool. See this shit? You can long divide it, yes? Very exciting. But now watch this. Holy crap. Real quick, this is so cool. You can do this a lot. You never have to do this ever. You never have to do this ever. You ready? I'm like, oh, just do it, Jeff. Ooh, look what I did. Ooh, look what I did. I'm so cool. Is everybody cool with what I just did? Did I change the problem? Nope. You just did nothing, Jeff. Thanks. Thanks, man. You're like the best. Can I do this now?
Yeah.
Can't I factor that? Won't the x minus 1 piece cancel? Didn't I just freaking do long division without doing long division? You guys see that? Long divide and then this is the remainder? Do you guys see that? Is it always easy to do what I just did? No. But I'm hoping maybe some of you guys kind of look out for that. Yeah? So when the degrees are the same or the top degree is higher, you must long divide. But this is kind of a nifty way. Now this one was kind of nice. It was easy and you could kind of see it. You just had to subtract 1 to make that work and then you add 1 to make it legal. Yes? So if I saw x minus 3 down here, what would I have done?
Minus 3 plus 3.
No. If I saw x minus 3 down here, I would have subtracted. No. Think about factoring 9. I would have subtracted 9 and added 9. Yes? Now, again, everything I just did completely on the side, you never have to do that shit ever. How do I long divide? You do this, yes? What can I give myself? Some placeholders, yes? How do I start this off? You guys remember? X. X goes into x squared down. In fact, real quick. Just suffer with me for a second. I'm gonna let us out early, okay? I'm gonna let us out early. Hold on to that. There's a light at the end of this dark tunnel with Jeff. How would you begin to long divide this shit? Can somebody really think about what you do? What would I put on the top? And exactly why? You can do it. No, I'm sorry. No, I'm sorry. Go away. That. What would you put up top? You can do it, come on. Yes?
Would be a 0 for the first digits.
Uh-oh.
I even had to.
You're not going to think 71 into 539. You're going to think 7 into 53. Yes? Is anyone catching yourself doing that? Wouldn't you put a 7 up here? Because 7 goes into 53. Did you care about the 1 first? No. What if that was wrong? Well, then I would adjust the damn thing. But the first thing I look at is first digit into this first 2. Now 7 times 71 is 497. So, when I'm doing this long division, do I give a shit about this minus 1? Nope. Same way to give a shit about that 1. X times what is x squared? X. 7 times what is about 53? 7. Okay. So x times x is x squared, correct? It's fascinating. When I put that 7 there, what do? Do I just multiply it by the 70? No, I also multiply it by the 1. So when I put that x there, I multiply by the x. And then multiply it by the negative 1, yes? What would I do next up here? That's right, I would change the sign of this. So I'm going to change the sign of this. Yes? This is coming back to you. So what steps do I take to long divide polynomials? The exact same steps we take to long divide numbers. Why? Because polynomials are numbers. They have to act the same exact way, yes? Variables are numbers. They must act the same way. So these cancel. What's 0? X plus x. X. Bring down the 0. X times what is x? 1. 1 times x is x. 1 times negative 1 is negative 1. Change the signs. Add. There's my remainders. The same shit I got. Quicker. Nah. Okay. By the way, that's part of my circles, not 11. Okay. Are you guys okay? Alright, you just gotta practice. It's not hard. Do you remember synthetic division?
I remember talking, but I didn't like it.
I remember going to your office hours for it.
Gotcha. So I think at one point I was considering printing that out, but
I remember the little box in the corner with.
so let me just start it off and see if this looks familiar to anybody.
Don't you do like -2?
The 1 comes down, multiply, add, multiply, add, multiply, add. Then the answer, I divided x cubed stuff by x stuff, so now my answer is x squared minus 6x plus 17 minus remainder, which is much, much cleaner than long division. And just suffer with me a little more. I don't know why I ask you, because I'm going to do it anyway, but I want to make it seem as if this is democracy. What would the first steps be here? Would I do like x squared times x is x cubed? Yes. I'm not going to do this whole thing. Yes. Plus 2x squared. Then I change the sign. -4 minus 2 is -6. Yes. And I bring this shit down. -4 minus 2 is -6. Do you see that? Synthetic division says, what are you doing, human? What the shit is all this shit? This doesn't matter. Why did you write it? It's going to cancel every damn time, you silly person. Let's just focus on the shit that matters. Just the coefficients matter. Yes? That's synthetic division's job. Now, am I saying right now that you're going to have to do this? Am I saying that in general, if you're going to do any frickin' math, is this good shit to know? Hell yes. Or you can just always long divide. You can just always do these things. Okay. Go. So, you requested one more, right? I think? No? Yes, you changed your mind, people? Do you have any opinion? Do you want to do one more or no? It's up to you.
Yes.
Yes, okay. So all I needed was one. Did I already pick one? Did we do one? No, I sort of got sidetracked. Let's pick one that's not too crazy, is that all right? Like, maybe not, I mean, real quick, what would the first step be on number 18? Yeah, always try to factor, but do you see how the bottom factors but the top won't? I don't know if you guys see that. So the first step on 18 is the long divide.
Divide the top.
So if the top degree and the bottom degree are the same, or the top is higher, you must first long divide. So let's try how about number 17? Ooh,
Yeah.
why? Sorry.
17.
What about 17?
The top degree is high. It's
The top
lower.
degree is lower.
lower.
What degree is the bottom?
3.
Third degree. Do you guys want to do this one? Has got a repeated dude, or do you want to do one like number? Let's see. Do that. Oh, look at number 28. Ooh. All right. Let me show you 28. Okay. And then I got one thing to show you, and then we'll leave early, like I said. The class is over 7:35. Yes, yes. God, I gotta keep all my classes straight. Okay. So I'm gonna let us out quite a bit early, so I don't want to hear shit. What did I say it was? This one. Yeah, this one here. Okay. So everybody copy that down. Jeff, just put your freaking glasses on. Okay. All right. Okay. So help me out. Help me start to set this up. So the bottom is x squared plus 1. What must the top be? What degree is this? Yeah, so it must be the most general first degree you can do. So if the bottom was 4th degree, it would be, the top would be ax cubed plus bx squared plus cx plus d. And then you go cry into a pillow or something, because that sounds horrible. What's on the bottom of the second dude? Good, because I got a, x squared plus 1 squared, yes. Because I got a repeated dude. But what goes on the top of that one? Just another what? C? X plus D. There. Again, the thing that's repeated is second degree, so both things have to, I'm sorry. Yeah, second degree, so the top has to be first degree. 1 degree less.
And you just factored the top, and that's how you got the ax plus b.
No. This is second degree. The top must be the most general first degree.
Yes.
So if this was third degree, this would be ax squared plus bx plus c, the most general second degree.
I'm just confused as to why there's more, like, how did you get the ax plus b and the cx plus d?
This guy needs a linear, because he's squared, so he needs a first degree. This guy's squared, so he needs a first degree.
Okay.
This 2 just means it's repeated.
But why is there the plus b and the plus d added onto it?
What's the most general first degree expression? Give me a linear function. First degree, right? That's linear. In fact, what's the equation of a line? What's the equation of a line? Y equals mx plus b. Mx plus b. We just call it a instead of m. What's the most general second degree? Ax squared plus bx plus c. So if that was third power, I would have put ax squared plus bx plus c. When I do the work, is it possible one of the letters ends up being 0? Yes. Do I know that ahead of time? Nope. So I cover my ass fully, and I put everything it could have been. So I have to put the fullest, most general second degree. If this was third power, this is second power, so I need the most general first degree. Okay. So what's next? So I'm gonna multiply both sides by the denominator, so what's this guy gonna pick up? Good, and what's this guy gonna have happen? His entire denominator just cancels. Poor little dude. Is this a situation where I could pick a value of x to help me out? Not really, no. There's no value of x that would kill any of the letters I'm trying to solve for, yes? Do you guys see that? Damn it! So then I just have to multiply this business out. And then if you want to, you can gather your like terms together like so. Do you see that? And now you can more easily equate your coefficients. What's the easiest thing to see there? A is 0 because there's x cubed on this side but none on that side, so A must be 0 to make this a true statement. A is 0. He's the real hero. Yes?
So when you have to do ax plus b, and you have to multiply the denominators, then the exponent drops.
If I multiply everything by x squared plus 1 squared, yes? One of these cancels, so this one picked up 1. Both of these cancel, yes? I was just trying to show you earlier a shortcut so you have to write less. Yes?
Is that a b in front of the a plus x in the second one?
You never know. In front of the a plus x in the second one.
Right there.
Here?
Not after it.
Here.
That's a b.
That is trying to be a b. Yes, okay. Okay. Yeah, I'm sorry. I'm just all about ideas, so writing is kind of secondary. I don't know if you picked up on that. Can anyone see what b has to be? Because what's the only x squared term here?
It has to be 1.
So b must be 1, yeah? Okay.
Why a 0?
What's in front of x cubed on this side? And what's in front of x cubed on this side? 0, right? So I could say how many x cubes? A of them. How many x cubes? 0 of them. So A has to be 0 for these to be equal to each other. Okay. What's A plus C have to be?
1.
1. And A is 0, so C is 1. And what's B plus D have to be? 1. And B is 1, so what's D have to be? 0. So like I promised earlier, sometimes you will find out later that some letters you chose are 0. You have no idea at first. It just happened to come out that way. So how do I rewrite this business then? How do I rewrite this? So let's see. A is 0. B is 1. C is 1. And D is 0. There. And I would almost always go ahead and break your parts up into 2 separate integrals or 3 or whatever parts, yes? Does anyone know how to integrate this? This is part of what I gave you in the blue box, remember?
Oh, isn't it the inverse tangent?
Yes, it's the one that shows up the most. That's inverse tangent of x. How do you guys, how would you do this one?
Bring the
Don't
x,
do partial.
bring the x squared plus 1 up to the top.
No, don't do that. U-sub. Why U-sub? Do you see a piece that's stuck somewhere?
Oh.
X squared plus 1 is stuck somewhere. What's its derivative? Something x, and then x is up top. Do you guys see that?
Got it.
I don't care what you just did. If you write an integral down, reanalyze it. And what do you always rule out, no matter where the integral came from?
U-sub.
U-sub. We created that integral from all this work we did. But it's a new, it wasn't there before. So let's look, all right, does use up, oh, use up works. Right? Okay. And then, blah, blah, blah. Okay, so you integrate it and you get inverse tangent of x, and you do u sub on this. Last thing I want to do, right? Hopefully you guys are cool with that. Yes, the u sub should be easy. I said earlier I wanted to show you. Remember we had, oh shit, the half. What was it, Jeff? Oh, it doesn't matter. If I had like x plus 2 squared, yes? And then somebody could say, well, why don't you put ax plus b over x plus 2 squared, Jeff? You guys with me? So now watch this. What if I had 4x plus 7 over x plus 2 squared? Yes? Isn't this 4x plus 8 minus 1 over x plus 2 squared? Just watch. You guys with me? I haven't done anything insane yet. Isn't this 4 times x plus 2 over x plus 2 squared minus 1 over x plus 2 squared? And isn't this 4 over x plus 2 minus 1 over x plus 2 squared? And that's why we have a over x plus 2 plus b over x plus 2 squared. I do not need bx plus c over x plus 2 squared because that would reduce down anyway. I just need those two parts. Does that make any more sense? It would work. You would eventually get like b is 0, but you would have all these extra letters running around you didn't need. Okay. All right, that's plenty. I'm going to let us out. Good night. Don't get used to it. 20 minutes early. Nice long weekend, yes? Dear God, I need it. I know you probably need it. See you next week. Week of quizzes. The walk. We're having a walk next week. Week of quizzes. Yay. Oh, by the way, the quiz on Thursday will just be on 7-4. The quiz on Tuesday is 7-1 through 7-3. These kind of problems can be kind of big, so that's perfect. We'll just have a 7-4 quiz Thursday.
So Thursday is only part fractions?
Yes. Only integrals that you require. Yeah.